What is going on, guys? Welcome back. In this video, we'll be talking about one-sided limits. This is a follow-up to our previous video, the introduction to limits, where we talked about briefly one-sided limits, but really didn't go into depth due to time issues. So let's just really hop right into it. Okay, so in the previous video, we said, okay, well, if we zoom in, so if we want to take a limit of a function, or if we want to look at values close to a value as we approach a value, how does the function behave? All right, so limit as x approaches a of f of x is equal to L. Well, the limit has to split into two parts. All right, we have a limit from right and a limit from left. So we look at the values coming from the right, or the greater than x, the approaching value. So this is a greater than 2, or x greater than a, and this is x less than a. Okay. Well, pretty much what happens is, okay, we split the limit into two parts, and they're one-sided limits. The limit from left, the limit from the right, which is the value is greater than a, and the limit from left, which is the values less than a. All right, we don't really care about what happens at a, but we're more concerned about as we approach a from the left and the right. Okay, so pretty much what happens is, okay, well, drawing a general curve, a random curve, okay, and we label this point A, okay. All right, we want to find the functional value, or what happens to the function as a approaches 0, or as the function as we approach a on the x-axis. Well, coming from the right, it looks like it looks like we're getting closer and closer and closer to this point here, and coming from the left, all right, it looks like we're getting closer and closer and closer to that point there too, and that point's labeled L. So the limit as x approaches a from the right is equal to L, and this is the limit as x approaches a from the left is equal to L. So that means the two-sided limit, therefore the two-sided limit as x approaches a is equal to L of f of x, of course. Okay, so now let's do an example looking at limits. Was specifically looking at one-sided limits. Okay, so all right, so let's let this function be f. Okay, and we want to find out what happens to the function. So what is the limit as x approaches 0? As x approaches 0. Okay. Okay, so first off, we look at from 0 from the left. So values coming from the left. Okay, so we're tracing it, and we get, okay, well, values from the left here. All right, and it looks like it stops at this point 1. Okay. Now, so it looks like it's getting closer and closer and closer and closer to this point 1 from the left. So our limit from left is 1. Now, looking from the right, well, there's a jump. All right, and so the limit is, we trace from the right, and as we're getting closer and closer and closer and closer to the points, it looks like it's getting closer and closer to 2. All right, if you guys remember, we don't really care what happens at the points. We care about what happens around the point. So we can have a hole in the graph, and the limit could still could still exist, but the function won't. All right, so the limit from right is equal to 2. All right, and so because limit from left and a limit from right do not exist, the limit as x approaches 0, the two-sided limit does not exist. It's not 0. It does not exist. DNE. All right, and so another case of that would be if the function's undefined. Undefined functions. Undefined functions for limits, for either limit one-sided limits. That does not exist. And also oscillating functions. So oscillating functions without a restriction, actually. Functions without restriction. Limit does not exist. Okay. So let's do an example, okay? Now, alright, so limits don't have to approach a value, or they don't have to exist. Alright, we'll talk more about this about infinite limits but really, we can have infinite limits, but alright, in the traditional sense that they don't exist. But if we expand our ideas of infinity, especially for integration, advanced integration techniques, well, we can have limits that go off to infinity and negative infinity, and even zero. And so pretty much, alright, so we're going to be doing an example. Find the limit as x approaches 0 of 1 over x squared. Okay, and so we're not going to make a table. We're just going to be tracing the limit from left and limit from right. And as you guys know, this is a rational function. If you guys don't know what a rational function is, go check out that rational functions playlist down below. It'll be linked in the card, and it's also on the channel. And so pretty much what happens is, okay, well, we're going to be looking at the limit from left and the limit from right. So from the left, alright, so we're looking around it. So from the left and from the right. So as we get closer and closer and closer and closer and closer to this point, there's an asymptote. And it wants to reach this asymptote, but it will never reach it. So the function just says, you know what, screw it, and we'll go off to infinity. And so the limit from left is equal to infinity as we approach 0 of 1 over x squared. And so we take the limit from, so now we look at the right-hand limit. So as we get closer and closer and closer to the point 0, the right-hand function does the same thing. It's trying to reach 0, but it will never reach 0. It will just keep going off and off and off and off, closer to that asymptote, but it'll never touch that asymptote. So it just keeps getting larger. And that goes off to infinity. So then we have the limits as x approaches infinity, or as x approaches 0 of 1 over x squared is equal to infinity. Alright, so that's all the time we have today, guys. I'll see you guys next time.